In this video, we're going to continue with solving multi-step inequalities, but this time we're going to be looking at special solutions. So very similar to what we talked about with solving equations with special solutions. So before I get into anything else, let's review the different symbols. So first of all, with inequalities, we have 4. So we have the less than sign. So we would say something like 4 is less than 5. We have greater than. So we could say something like 5 is greater than 4, which is the same statement, it's just flip-flopped. We would also say less than or equal to. Now remember, the equal to allows me to say statements like 2 is less than or equal to 2, where we wouldn't want to say something like 2 is less than 2 because that sounds weird. We could say an equal to because that's fine, because 2 is equal to 2. And lastly, we have greater than or equal to, which does the same thing, it's just flip. So before I get into the special cases, I want to go back to a problem that we talked about in the video with special cases of equations. So we were looking at solving bags of pretzels. Now, if you forget that problem, you can go back and look at how to solve this. It's in the solving special equations with special solutions video. Well, we have 2 towns, and we're looking at the sale of pretzels. And so we see in town A, they've already sold 1,200 pretzels. Town B, they sold 800 pretzels. And we see that on average, both towns are selling 100 bags per day. And so we were asked to find after how many days would the 2 towns be the same. And so we defined X to be number of days. And so our equation, we'd have town A and town B. So town A would be 100x because we're getting 100 per day, so times the number of days, plus 1,200. And we would set that equal to town B, which is 100x plus 800. Before even setting this up, we could rationalize that these 2 towns will never be the same because they're selling pretzels at the same rate. So since they have the same rate here, they will never be equal. And so we would say no solution to this problem. Before we even solved it, we could look at it and say no solution. But from the equation, if you remember how we would solve this, we would move 100x, so subtract 100x from both sides. And well, 100x cancel, 100x cancel, and I'm left with 1,200 equals 800. Since these 2 numbers are not equal, we have no solution. So we would solve it, we would cancel out our variables, and we would get 2 numbers that aren't equal to each other. So this is no solution. Now what we're going to see with inequalities is that the same thing can happen, it just looks a tiny bit different. So let's jump into it. So here I have an inequality. Got 6m minus 5 is less than 7m plus 7 is less than m. So if you remember, we solve this like we would an equation. But we still follow our steps and look for the distributive property. Well, there is none. So I'm going to go ahead and combine like terms. So there's nothing to combine on this side. Is less than. I'm going to combine these m's. So 7m take away 1. So I have 6m plus 7. Then I go ahead and I move my 6. So I move my 6m. Okay, so that cancels out. So I have minus 5 is less than 7. Now for this problem, we've canceled out our m's, and we see negative 5 is less than 7. Now, is this a true statement? Yes, it is. So this problem isn't a no solution problem. Since this is always true, we call this an all real number solution, meaning that you can put any number into this original problem, and then it's going to come out to be the same thing. We could have figured that out right here. Because 6m minus 5, 6m plus 7, well, if I'm adding 7 to a number, it's always going to be bigger than if I'm subtracting 5 from that number. So we could have figured that out at this step. So this case is a special one, is when we solve and we get a true statement, that's when we have all reals. Now, if we were to graph this on a number line, it's actually a really easy graph. All you would do is we would have a number line. Let me change colors here. And if we're looking at all reals, that's just the number line. So we would draw an arrow or a line with an arrow going in both directions because it's all real numbers. It's every possible number you can think of works. let's take a look at another special case. So for this one, we've got 5 times 3 parentheses x minus 5 is greater than 3x minus 5. So let's go ahead and organize our work. So I'm going to draw a line down the middle to help me organize. Well, kind of a line. And I'm going to start with distributing. So let's distribute this 3 to inside the parentheses. So 5 plus 3x minus 15, make sure we multiply, is greater than 3x minus 5. Next, let's go ahead and combine our like terms. So let's combine the 5 and the negative 15. So we get 3x minus 10 is greater than 3x minus 5. Excellent. Now let's go ahead and move our variables. So we see here minus 3x minus 3x. So we would have negative 10, these cancel, is greater, these cancel, so negative 5. Now, unlike the problem that we just did, this is not a true statement. Negative 10 is not bigger than negative 5. So when you get a statement like this, we would say no solution. There is no number that you could plug in for x to make this inequality true. So when we're solving inequalities, just like equations, there are 3 possible outcomes. And they're the same possible outcomes we have with an equation. So we could have a 1-number answer. We'll put that in quotation marks, quote unquote. So we could say x is less than 3. Now remember, there is still an infinite number of answers. Infinite number. But they're restricted. So we would say all the numbers smaller than 3. So there's kind of a 1-number answer. It would look like this. X is less than something. X is greater than something. But remember, there's still an infinite number of possibilities. But we'll say 1 number. The other possibility is we could have all real numbers. Now, this is when we solve it and we get a true inequality. So 4 is less than 5. Or you would get negative 10 is less than negative 5. Something like that. And the last possible outcome is we could have no solution. That's when we solve it down and we get an inequality that's never true. So 4 is greater than 5, but we all know that's not true. So that concludes our special cases of solving inequalities.